Welcome to Talent Talks, where we explore energy, AI, entrepreneurship, and investing with the experts building the future. I'm your host, Charlie Lycum, and I'm thrilled to introduce Chris Miller, author of Chip War, who holds a special place as both our inaugural keynote speaker in our Leadership Speaker Series, but also our first podcast guest. Chris spoke at our event this past October, and today we're sharing insights from his keynote. Let's get started. Welcome, Chris, to Houston and to our podcast.
Well, thank you for having me.
We're excited to have you here in our first podcast at Talon. Before we get into Chip War, tell us about your background. How did you get to Harvard undergrad and to Yale for grad school?
I was always interested in studying history. It was my passion as a kid, reading biographies of great leaders and reading history. And so I wanted to focus my academic work on that. And so I was an undergrad at Harvard, went to do a PhD and focused on Russian history initially, which is a country that has long fascinated me and still is an area that I focus a fair amount on.
Do you speak Russian? Did you learn Russian in school?
I do speak Russian. I lived in Moscow for a couple of years. So I had a chance to polish my Russian well there. And I still spend a fair amount of time in Russian language sources and reading the Russian newspaper. And it's a fascinating language and culture.
How many years were you in Russia? Were you studying there, or was it more for work?
I was studying there, then I taught at a Russian university for a year. So I was there for 2 years in total. So I left in summer 2014, which is right after Russia annexed Crimea. So I was there for the kind of the transition from relations with the US and Ukraine being very stable to the beginning of the downwards. Never met Putin, no. Met a bunch of other folks in government, but never Putin.
What brought you back to Massachusetts and to Tufts?
Well, I was offered a position to teach history at Tufts in a School of International Affairs, so combining the study of history with the present day application of it, drawing lessons to understand international politics, but also to spend more time on technology issues, which I was beginning to focus on as well.
And have you taught while being at Tufts, or has it been primarily research?
A mix of both. I'm right now teaching courses on Russia as well as on international politics more generally.
So at what point did you begin to research the semiconductor industry? What was the catalyst to get interested in that industry?
What really came out of my studies of Russia, I wanted to understand how it was that a country that was so good at science, so good at engineering, won so many Nobel Prizes, produced so many brilliant physicists and chemists, was so bad at computing. And it seemed like a puzzle, both because of the intellectual firepower, which was there, but also because computing was so important to the Cold War arms race, which the Soviet Union was a central participant in. They knew it was important. They just couldn't build the industrial capacity that they needed. And that seemed like a real puzzle, especially in comparison to rocketry, which they were very good at. Getting the first person in space, the Soviets beat us to that. But when it came to computing, they were far, far behind.
Fascinating. And at what point did you decide to really dive more deeply in actually writing a book about the industry? Was there a paper initially that kind of launched it?
It was really as part of this research, I realized first just the absolute centrality of computing to military power, which I guess I'd been vaguely aware of, but just the central importance of computing to enabling precision strikes, to advanced aviation, and then coupling that with what the trends I was seeing in the present day. First, the reliance on Taiwan to produce almost all of our advanced chips. And secondly, the dependence that China still had on importing semiconductors from abroad, which also seemed like a puzzle because China can manufacture pretty much everything else, but still can't manufacture advanced chips at scale. And so I realized that there was a story that actually stretched from the start of the Cold War all the way up to the present. And it involved a technology, chips that I knew existed, I knew were important, but I hadn't really realized how pervasive and central they were and how important they would become.
At what point did you broaden the study of the semiconductor industry beyond Russia or beyond the US and take it to a much more global research project?
It was really when I realized you couldn't understand chips today without that global view. When the chip industry was started, it was started here in Texas and in California with individual companies that really had capabilities across the supply chain, as we described it. They did the materials, they did the design, they did the manufacturing all themselves. And today, no one does it by themselves. Everyone relies on customers or suppliers in Europe and Asia and North America. And so you can't understand the technology today without that global perspective. That took me to Taiwan and Korea and Japan, as well as to Europe, to understand how these interconnections actually worked.
In the US, you mentioned Texas and California. What was that sort of founding moment in the US industry? Was it a corporate enterprise? Was it tied to the US government? Like, what was that kind of founding moment maybe in Texas?
It was a mix of both. In the late 1950s, there was an effort to make guidance computers small enough to put in missiles or in spacecraft. So the Apollo spacecraft, for example, was being devised at the time, and they needed a computer small enough to make it to the moon and back, but powerful enough to make it there and back as well. Same thing for missile systems. If the U.S. government was working with companies like Texas Instruments here in Texas, or like Fairchild Semiconductor in California, to miniaturize these computing devices. And in so doing, these companies learned that they could both use them for defense systems or guidance systems, but also for corporate and consumer systems. And so very quickly, you had the birth of an industry for the civilian economy. And it turned out the civilian economy was 10, 20, 30 times larger than the demand for military-focused chips started out as.
How did you take such a technical subject and make it really appeal to the mass audience?
Well, I think it was key to me that you both had to analyze the technical aspects, understand as much as at least I could the science and the engineering, but also put that next to the business and the politics. Because if you only looked at the technical changes, you wouldn't really understand the rise and fall of different companies, for example, or the different ways that governments tried to shape the industry. And it was by bringing the pieces together that actually you understood these broader trends. And so I made it a point at the outset to put the technical story next to the supply chain and business model and political dynamics. And I think that is what helped illuminate the importance.
Providing a bit more background on the book, you recount how chips evolved from niche components into strategic technology of our time. What's the single most surprising turning point you uncovered as part of the analysis of, again, the U.S. market, maybe more broadly the global market?
I think the biggest turning point was the decision to split the design and manufacture of semiconductors. For most of the first 30 years of the industry, companies both designed and manufactured chips in-house. And that was something that made sense when a chip would have 1,000 or 2,000 circuits carved into it. But today they have 20 billion. And so to manage that complexity, companies have had to specialize, which has been a real driver of progress. But it's also had interesting and complicated results. So the key manufacturer today, which I'm sure we'll talk about, is a company called the Taiwan Semiconductor Manufacturing Company, TSMC. They've been both a real enabler of technological progress in the US, because US firms that design chips have benefited from its extraordinary capabilities, but it's also raised real questions about our dependence on manufacturing overseas.
When you put in context the semiconductor industry to previous other big global commodities or markets, the oil market, innovation on railroads, what analog would you characterize as sort of the best historical analog to the growth of this industry?
Well, I think, as a historian, we're never supposed to say that we have a historically unique case, but I think there are a couple of dynamics that do make semiconductors really hard to compare with almost anything else. Two stand out to me. One is the rate of innovation. So in most economy, productivity improves by a couple percentage points a year. GDP grows by 1, 2, or 3 percentage points a year, depending on which year we're in. In the chip industry, progress improves at almost 50% a year. If you're not racing forward, you're falling far, far behind, which means that over decades, we have doubling after doubling after doubling, which is why your and my smartphone both have more computing than the Apollo spacecraft. No other industry has seen that rate of progress. That's one difference. And the second is, because of that, we have much more concentration in the chip industry than really anywhere else that we see. Every segment of the supply chain is dominated by just a handful of firms. And so, in oil, we talk about OPEC playing a big role in the 1970s, but it was producing, at the time, 20, 30, 40, 50% of the world's oil, a small fraction relative to TSMC producing 90% of the world's chips. That concentration is also pretty unique.
Touching on TSMC and maybe Taiwan broadening out of the US, maybe let's get into the geopolitical sphere with China, the US, and Taiwan.
I think the key dynamic is that the US relies on Taiwan to manufacture all of its chips. And it relies on China to assemble many of the devices that chips go into: smartphones, PCs, all sorts of consumer and industrial goods. But China is equally reliant on Taiwan to manufacture many of its most important chips, and therefore is reliant on U.S. know-how, U.S. machines, U.S. intellectual property, which are critical inputs into the Taiwanese manufacturing systems. There's a very uncomfortable interdependence where all three parties rely on each other for markets or for technology. No one wants to be reliant, but no one can find a way to become self-sufficient, at least not yet. And self-sufficiency is going to be enormously expensive if it's ever achieved. And I think there's still real question marks as to how far it's even plausible to go in the pursuit of self-sufficiency.
Which is why I think President Trump was not crazy when earlier this year he tweeted in all caps that the whole electronics supply chain is a national security concern. It might have seemed a little bit of a stretch to describe one of the biggest segments of the US and global economy as a national security concern. If a huge economic sector is a national security concern, then you might ask, what isn't a national security concern? But I would posit that as you think through the implications of more connectivity plus semi-autonomous operation, it's actually quite reasonable to ask very hard questions about where you're sourcing your components from, not just for the most sensitive systems, but even for shipping cranes or autonomous driving systems in your car, or any sort of robotics applications, or the telecoms network, or indeed data centers.
Speaking of interdependence, I'm struck by in the book you talk about the 1980s and the US versus Japan dynamic, which appeared to resolve and coexist peacefully. Is that potentially an analog that could be used looking forward 5, 10, 15 years with China, or do you think that's naive?
I think that's the optimistic view. I hope it's the right analog. I think that the difference between the US and Japan then and the US and China relationship now is that US and Japan were economic rivals, but political and military allies. Whereas today, the US and China are economic competitors, but also political and military competitors. And that makes the economic relationship much more adversarial than even the US-Japan relationship was. So I don't think we should assume that we're headed towards a very negative outcome vis-a-vis China, but I think the competitive dynamics are real and we can't ignore them.
What's so fascinating about the book is you get into even the detail around the supply chains, tooling for these facilities, the materials used in the fab process. All of these appear to be an incredible symphony of just interdependence and also coordination across a lot of different players. Have you identified choke points or potential bottlenecks that could be an impediment for significant additional growth?
There are a lot of choke points across the supply chain. Really, everywhere you look, there are choke points of differing severity. In the tools which you mentioned, there's a number of types of tools that are produced by a single company. The most prominent would be ASML of the Netherlands, the only producer of extreme ultraviolet lithography tools. But then if you go to the chemicals, the materials used for chip making, there too, you often have materials produced by just a couple, or in some cases, one company that are capable of refining and purifying the material to the right level. And then you go to the deployment of chips. And today, if it's AI chips, in addition to actually making the chips, which is hard, finding the power to deploy the chips is now a choke point. And it's a choke point because transformers and other equipment is in scarcity right now. So really across the supply chain, there's many single points of, if not failure, at least single points of bottleneck, which have been a real challenge the last couple of years to work through.
Do you think reshoring some of that fabrication capacity in the US, I think you're even in part in Texas now as part of a big effort on the part of the state. Do you see that as a step forward for the US in terms of vertical integration?
It is very important. I think we also need to be measured in our pursuit of onshoring. I think the reality is the industry has benefited from access to global markets and from the ability to benefit from technology in Europe, in Japan, in Taiwan, and Korea. And so we've got to strike a balance between doing more onshore, which I think has to happen, but also not being so insular that we lose the economies of scale, as well as the technological relationships that have really powered innovation.
Maybe talk about the trip to Texas.
Well, there's a ton of new activity in Texas right now. We mentioned Texas being one of the focal points of the early chip industry, and I think Texas is now at the center of the revitalization of the U.S. Chip industry, whether it's chip design. You've got major semiconductor companies headquartered in Austin, for example. Chip manufacturing with both Texas Instruments and Samsung building major new plants in Texas. Advanced packaging, so finding new ways of bringing different types of chips together more efficiently. There's a lot of research being done on that in Texas as well. There's really across the supply chain an effort by both companies and the state government and the universities to push forward innovation and next generation manufacturing. And I think it's not a coincidence that so much of the new investment in the chip industry in the US is actually happening here in Texas.
Of course, we're in Houston, and we'd like to think of it as the energy and power capital of not just the US, but the world. How do you put into context the dynamics of power vis-a-vis the semiconductor industry requirements?
I would posit to you that there's no bet that the United States has made that is more significant than our collective bet on computing power. Economically, financially, militarily, we're going all in on computing to define our future, which means we better make sure we win the technological race. China's going all in too. And so it seems to me we've got a real challenge ahead of ourselves.
We're finding tons of energy efficiency. The challenge is our demand for compute is so much more rapid in its growth rate that we just need more power deployed to especially data centers today. As we build better AI systems, and more importantly, as we deploy them at scale, it's going to require a lot more power. The debate is, will it require only a lot more power or a whole lot more power, tons more power? Everything I hear from tech companies, data center developers, is that their number one constraint right now is access to electricity.
As you look at the market cap of some of these largest semiconductor companies, we talked earlier about Nvidia going from a $4 trillion market cap to a $5 trillion market cap. Does that give us a little bit of a guide as to what I think the market at least is expecting in terms of demand for these products, but by extension, the power specific requirements?
It does, and it's certainly pulled more capital into the entire power generation supply chain, which is a good thing. But I think it's also worth noting, if you look at where Nvidia itself has been making its own investments over the past couple of months, it's investing in power too, because it wants to make sure that this bottleneck does not limit its ability to sell chips to customers. And the same is true for its key customers, Google, Amazon, Microsoft. They're all becoming really top scale power investors because it's one of their biggest problems.
The book was published in 2022. It's been 3 years since the original book publishing. I think ChatGPT was released a few months after your book was published. Maybe just catch us up from those that have read the book to today. What are some of the biggest things that have surprised you in terms of development?
Well, I think that is the big change, is the AI boom. I had one chapter on Nvidia in the book, and had I written it, knowing what would have happened, I would have put Jensen's picture on the cover, I think. It was already obvious that AI would require new and better semiconductors, that AI would bring new capabilities, but everyone was surprised, myself very much included, by just the rate of technological progress, therefore the rate of investment. And that's reshuffled the deck in the chip industry. In 2022, Nvidia was still a medium-sized semiconductor company. Intel was still at the center of data centers, and that's now reversed. The entire way data centers are architected has been totally transformed by the unique needs of AI, including all of the power that's required, which needs new cooling and new transformers and new power management. So all that's been changed by AI in a really dramatic way.
You mentioned Nvidia, and maybe just kind of diving into the book on one question related to its CUDA, specific technology. We're reading a lot now in the newspapers and in the technology news outlets that Google and Meta are looking to do in-housing of some of their specific alternate technologies. What is your view as to whether Nvidia can maintain its current number one position for supplying the entire industry versus in-house manufacturing and design?
I think in-house is a trend that actually has a longer history. Even before ChatGPT, Google already had multiple generations of its own in-house AI processor. Amazon had already been buying AI startups. So this is a longer running trend. The challenge that all the in-house processors face is this. Nvidia is the world's largest company. They're going to invest more money in R&D for AI chips than anyone else by a factor of multiples. And so keeping up with that rate of progress is a very, very hard thing to do.
So we need advanced chips for AI. But one of the paradoxes is that the more advanced chips you have, the more less advanced chips you need around that AI system. And so the growth in chips that are required actually scales up even more rapidly than AI would imply. Why is that? Because the more AI we have, the more sensors we'll use to collect data, and the more communications we'll need to transfer data back and forth.
It's certainly true that none of NVIDIA's customers want to have to pay such a large margin on top of every chip they buy from NVIDIA. But thus far, it's also been true that the general purpose flexibility of NVIDIA's chips is something that is really demanded in the market. And so long as NVIDIA is racing forward technologically and it has this very flexible architecture that works well with many different applications, it's going to be a very valuable product.
When you think about NVIDIA, the design of the chips, which do you think will be the biggest enabler for the chips keeping up with Moore's law versus falling behind?
It's going to be all of the above, actually. It's going to be better designs that are more optimized for specific AI workloads. It's going to be better packaging So moving data between different parts of the server, for example, is a key area of focus. Traditionally, data moved along copper wires, and so it moved at the speed of electrons transiting copper. It's going to transition to optical, moving at the speed of light between different chips. That'll be a huge change. It's going to be 3D stacking of chips. So Moore's law was traditionally about 2D, cramming more circuitry together on chips. Now they're being stacked 3D as well. So there's a bunch of different axes of improvement, which makes me optimistic that we're going to keep our current rate of improvement because we're not only relying on one method, there's actually a bunch of different ways you can push the technology forward.
If we look out 10 years, Chris, think about what will this market look like by 2035? How would you evaluate new fault lines? Who are winners? Who are losers?
I think right now in AI, the focus is on the data center with good reason. That's where AI systems are trained. That's where most of them today are deployed. As AI is deployed more broadly, though, we'll want a mix of AI systems in data centers, but others on the edge of networks. To give you an example, in an autonomous driving system in your car, you don't want to have to call back to the data center to know whether to turn left or turn right. Latency is going to be too high, safety issues are real. There'll be a lot of applications where you'll prefer to have the AI on the edge. I think we're in the early stages of seeing what will that look like, what architectures for the chips will be most efficient, and which companies are going to win that space.
And so if the trend of the last decade has been putting even more chips in our cars and our dishwashers, I think this trend has a long way to run, a very long way to run. Indeed, and that's especially true if you think we might possibly be on the cusp of major step change in our use of robots. Now, I'm not sure if we're headed towards rapid deployment of robots. I get nervous when I look at photos like this of robot armies walking out of China. But I do think that it's not crazy to imagine if you couple the existing advances in robotics with the LLM capabilities that have been developed the last couple of years, we're going to have major improvements in robotics capabilities. If you listen to what venture capitalists in Silicon Valley are saying, or indeed what they're investing in, you'll certainly see a lot of enthusiasm for robotics right now. And just like in cars and in household appliances and industrial equipment, robots also have a ton of need for advanced semiconductors, both in terms of the processing you need on the robot to think, and in terms of all the sensors and all the communications capabilities that they, like your phone, will require, which raises both interesting technological and business questions, but also huge security challenges. Huge security challenges, because the more semi-autonomous devices get and the more communications and remote access capabilities we devise, the more the question of trust and provenance of your devices comes to the fore. And this is going to be a very challenging issue for us to deal with because so much of our hardware is sourced from locations where we don't have a whole lot of trust in the provenance of it.
Is there one industry that you think will be most disrupted as we look out over 10 years?
But that's a hard question. I think the immediate industries that are already being impacted are those that have the least regulation and are already the most digitally forward. That's why you see software being the most impacted by AI. It's natural that those companies are early adopters, and it's an easy use case for AI. If you look at healthcare, tons of opportunity, but also tons of challenge in terms of the privacy regulations, in terms of getting a very complex network of actors to shift. And so I hope we adopt AI rapidly in healthcare. I worry it's going to take a longer time than we might like.
Thinking about corporations, governments, given the current geopolitical situation we talked about before with Taiwan, with China, with the US, when you think about what advice would you give corporations, even here in Houston, their opportunity to improve supply chains, improve resiliency?
The key problem most companies have is actually understanding their supply chain. Once you start digging into your supply chain, you realize that your suppliers have suppliers and they have suppliers, and your ability to understand and to get the information sharing that you might want and to track how that changes over time, it's actually very complicated. And from a raw material to a finished good, you often have dozens of different transactions, which are just hard to know and hard to map. And so information is challenge number one for most companies, and you can't manage your supply chain unless you've got that visibility into what it looks like today and how it's going to change over time.
Which our largest manufacturers have been learning in real time as they adjust to the Chinese limits imposed on the sale of rare earth magnets and other critical minerals over the past several months, illustrating just how little we know about our supply chains. If it was possible for our most capable manufacturers to be so surprised by their reliance on Chinese rare earths, which if you were even a casual reader of the Wall Street Journal, you would have known for a decade and a half China dominated and had been introducing export controls on a steady basis. If we were so surprised by this, just imagine all of the bigger surprises we have to come across our electronics manufacturing sector. And when you begin to dig inside of your electronic devices, you realize just how knotty and complicated this problem is.
When you think about near-term, long-term strategies that, again, maybe private sector corporations or governments to ensure innovation, what recommendations do you have for really driving that internally inside of organizations?
I think the key challenge that every technology has with adoption is that you need people to adopt the technology. And so people are always the roadblock to adoption. And so we need to make sure we're designing technologies that are as user-friendly as possible to get the median person in an organization to actually embrace it. And I think for leaders thinking about their organizations, that's the way to think about the key challenges. It's not finding the technology or not having a technology that's advanced enough. It's having technology that's simple enough to be used broadly that most organizations face.
Makes sense. One topic, which is U.S. government. Obviously, with the previous administration, President Biden had the CHIPS Act and the Science Act, really pushing the onshoring we talked about before related to some of the improvements in Texas. How do you view the U.S. government's ideal, optimal role in the context of helping improve U.S. competitiveness?
In the optimal world, you'd have a government that was investing in education, investing in basic R&D, basic science, but otherwise letting the market sort itself out. And I think in most cases that result is great. The problem is that we don't live in that world. We live in a world in which our supply chains are hugely reliant on Taiwan and China, in which China is catching up very rapidly in many technology areas, in which all these technologies are being deployed into military systems. And there are really direct lines you can draw between U.S. technologies and Chinese defense capabilities.
There's been, of course, a lot of efforts already to try to diversify supply chains. And if you look at charts of investment in chip-making facilities, you see there's been an extraordinary boom in building chip plants in the United States, largely in Texas as well as in Arizona. But if you look at chip investment in Taiwan, you'll find that it's still far outstripping even the rate of investment in the United States, which means that although we're becoming a little bit independent of Taiwan, this is going to be a long-term challenge to reduce our dependencies. And it's also going to require building out entire ecosystems that haven't existed in many cases for decades. Because for every single chip plant you want to build, you need chemicals and materials and, of course, a workforce, which is often the hardest issue to address from scratch.
Do you think investments into actual public companies is that right next natural step? You know, we've had the U.S. government invest in Intel and a few critical mineral companies. So far, it looks like the stocks are doing well. So maybe the investment decision is already paying some return. But what's your view of that?
I think we should be cautious. I think that there are cases where that might be justified, but I also would, as a general rule, rather have government setting the market dynamics and letting the market decide. So when it comes to critical minerals, would you rather have government taking a stake in individual firms or saying we're going to be a buyer of anyone's lithium or anyone's cobalt or anyone's NdPr at a given price and let the market decide who can best produce that? I generally tend towards the latter as the more efficient option.
You've obviously, published an incredible book with Chip War, really, I think, turned not just subject matter experts, but lay citizens really to this, critical topic. As you look forward, is there a next project? Are you continuing to kind of become more expert in this specific space? Would love to hear about how you're taking your research.
To be honest, the last couple of years has been so exciting in this space. And there's been so many adjacent issues that intersect with semiconductors. It's been hard to turn my attention away. I'm spending more time in the quantum computing space, for example, which is overlapping very substantially with semiconductors, spending more time in supply chains for power and for chemicals and materials, which are also adjacent. The more you dig in and peel the onion, the more you realize that there are so many fascinating industries that are right next to semiconductors, and you can't understand the semiconductor space without understanding these adjacent industries.
Hopefully we'll get a chance to collaborate in the power and energy sphere as your research maybe touches that area. All right, lightning round. This is really designed to get quick answers, although feel free to give us as much feedback as you can. 7 different topics. First, family, married, kids.
I have 3 little kids, 1 5, 1 4, and 1 years old.
Excellent. I'm very impressed with how you're managing through Chip War, your tough responsibility and family. Favorite sports team?
Chicago Cubs.
Oh, wow. Okay.
Long-suffering fan.
Okay. So not a Red Sox or Patriots.
Don't tell my friends in Boston.
Biggest passion?
Right now it's my family, spending time with my kids.
Any pets, dogs?
No pets.
This is a
no
compliment
pets.
to my youngest child. It
Gotta
had
toss that one
that
in there.
question. Okay, gotcha. What are you reading? Favorite book?
One of the books that I took as a model when I was writing Chip War, tried to aspire to, was Dan Yergin's The Prize, which I know you know Dan as well as a history that integrates both business history, technological history, and political history. It's, I think, a model for historians.
Favorite movie?
Star Wars.
Oh, excellent. Great. One activity for sport?
I'm a runner. I run most days.
Sounds like there was squash in the background.
There's
at one
squash in the
point.
background, less now than I would like.
Okay, you got to tell that anecdote just about your time at squash.
Well, my favorite place to play squash was in the basement of the U.S. Embassy in Moscow, where I lived for a couple of years. And so as a regular squash player there, I'm sure attracting the attention of the Russian intelligence agents who were tracking who was entering and leaving the embassy.
That's fantastic. That's great. Let's see here. This is actually for my oldest daughter. Biggest consumer impact of AI over the next 5 years? Consumer electronics.
Everyone's waiting to see what OpenAI will release when they release their consumer device. I think for most consumers, AI is going to be primarily a search tool, both in terms of replicating what we do in Google today, but also searching for e-commerce. It's going to transform the way commerce works. And so I think in the next couple of years, we should think of AI as a better search tool. And that's not a limiting description. In fact, the business applications are essentially endless just in that one domain.
Last question for my son. Biggest technology passion? Sounds like maybe quantum computing.
I was spending a lot of time in the quantum space today. I still find myself fascinated by the semiconductor manufacturing process. And so every opportunity I get to tour a chip making fab or the facilities that make the tools that make the chips, I'm a real nerd when it comes to immense appreciation for that type of equipment.
Well, Chris, thank you for being our first podcast at Talon. We really appreciate it and look forward to continuing the dialogue with you. Really, really, and congrats on all the success with your research and with Chip War.
Well, thank you for having me.
I want to thank Chris for breaking down how semiconductors are reshaping global power and why chips have become the most critical technology of our time. If you enjoyed this conversation, please subscribe to Talent Talks and feel free to share with others. We'll be back soon with more conversations on energy, AI, entrepreneurship, and investing. I'm your host, Charlie Lycum. Thanks for listening.